Okay, we are in lesson 5.5, which is page 15 in your notes, and we're talking about proving right triangles congruent. So we'll be using the right triangle congruence theorem to prove relationships in geometric figures. Specifically, we're going to be looking at the HL theorem. Okay, so we are only looking at theorem 5.9, the hypotenuse leg congruence theorem. And this theorem states that if the hypotenuse and leg of one right triangle are congruent to the hypotenuse and the corresponding leg of another right triangle, then the triangles are congruent. So I want to draw this out. I'm going to draw, here we go, we got one right here. And we're going to copy that. Okay. And we can even, they might even be at different angles. We don't usually do that, but I'm going to point it out that they could be at different orientations. Okay. But if the hypotenuse right there is the same length and the corresponding side or corresponding leg. Now, legs are any side that isn't a hypotenuse. So this is a leg, and this is a leg, okay? So leg and leg, here we go, and hypotenuse. And we're just going to put H over here. Okay, hypotenuse and leg. Thus, we get our HL. All right, if those match up, then we also have a matching angle here. Okay, so we still have 3 matching pieces. Even though we've only got 2 letters here, HL, there are 3 pieces because there is an angle in it. So what I want you to realize is that really what you have is an angle, a side, and a side. So this is like 2 sides and a non-included angle. This is 2 sides and a non-included angle. Okay, and we told you in the last lesson that this was a no-no, okay? Only okay with the HL theorem. Okay, and we're going to make a much bigger deal about this when it comes to the law of sines and law of cosines. When we get to that stage, you're going to find out why. But for now, I want to point out that if you have an A, S, and an S, that's bad. Okay? Now that you're done laughing about that, we don't do that. No 2 sides and a non-included angle. So let's go ahead and try this. Let's see. Is this, and this is, by the way, an Alex topic that you're going to be doing. Is this an HL congruence property? So let's look at A. So we've got a right triangle. Both of these are right triangles. They've got that 90 degrees. They have a matching leg, and they have a matched up hypotenuse. See that? They go from the same begin to the same end, so they match up. So yes, they have a hypotenuse and a leg that match. Good. B, no right angles. So we can stop right there. C, they have the right angle. Check. They've got, so there's check, check. They've got a matching leg, but the hypotenuse does not tell me that those are matching. So that's a no. And then for this one, they have the right angle. Good, check. They've got a matching leg and a matching hypotenuse. So they've got a hypotenuse leg on a right triangle. Yep, that is an HL. Good. So there we go. We should have yes, no, no, yes. Good deal. So let's try this. I'm gonna go down here. And this is a walkthrough that you are filling in the blanks in yours. This says Craig and his brother are painting a house. The brothers use ladders that are the same length, and they place their ladders in equal distance from the house. Will each ladder reach the same height on the house? Construct a logical argument. So they're almost asking you to write like a paragraph proof, which we don't really do, but that's what they've written out there. So they've drawn out these models to show these two ladders. See? There you go, at the 90 degrees here. They've drawn these two triangles, and they've drawn them in a two-dimensional format right there. Okay. So first they draw a diagram to model the situation. It's given that the length of the ladders is the same and that they are placed the same distance from the house. So that's what they drew, and they marked same distance, okay? Because the wall of the house is perpendicular to the ground, the triangles formed by the house, the ground, and the ladders are right triangles. That's one of your fill in the blanks. The hypotenuses are congruent because the ladders are the same length. The corresponding legs along the ground are congruent because the ladders are placed the same distance from the house. So the triangles are congruent by the hypotenuse leg congruence theorem, or the HL theorem. Okay. Thus, A, B, and D, E are congruent by CPCTC. You can conclude that the ladders reach the same height in the house. So I hope you've got your blanks filled in. What they're really saying is, if you drew out your models and you decided that they were congruent by HL, then that means that the height that they reached, A, B, and D, E, are the same. You can say AB is congruent to DE by CPCTC if we were writing out a two-column proof. Okay. Now, it is your turn. You are given this proof. Given that JKN and LKN are right triangles, and that JN and LN are congruent, prove that JKN triangle, or triangle JKN and triangle LKN are congruent. And I gave you a fill-in-the-blank proof. This is from Alex, okay? So you need to fill in the reasons. This will be one of your topics in Alex. So go ahead and pause me, fill this in, and then unpause me to get the answers. By the way, I would really recommend drawing all over the sky and figuring out your reasoning. Okay. Did you get that the first two answers are given, that Kn is congruent to Kn because we're reflexive, and that if you know all of those pieces, that it is by the HL property? I sure hope so.